Hello everyone. Welcome back to our journey through design principles. So, what we have today, it's diving into the world of the open close principle. However, before we jump into OCP, I highly recommend watching my previous videos on why solid principles and the single responsibility principle. Trust me, you will enjoy those videos. It really sets the stage and gets you all geared up for why these principles are super cool and important. Okay, let's take a quick look at what we have for OCP today. First, we will see what the open close principle is all about. Then we will jump into what ifs. What if we just ignore OCP? What kind of mess could that introduce in our code? We will dig into the potential headaches and hiccups that could pop up if we don't follow by the rules of OCP. We will then explore how to identify violations of the open close principle. Throughout this learning process, we will initially write code that does not adhere to OCP and subsequently refactor it to comply with the principle. So, let's get started. So, what is OCP? Let's first dive into understanding what open and close mean in the context of the open close principle. But you know what? Let's set aside software for a moment and explore this principle through real world analogies. Imagine you are building a house and working on the plumbing, the water supply for all the rooms. Say you have got this main water line coming in, and initially you have a connection to one of the washroom, something like this. Now say you decide to add another pipe connection to another bathroom. So what do you think? With this design, how can you accomplish this? Of course, with this design, you need to branch out the main line into different rooms, right? Here's where it gets interesting. You decide to use T-pipe connectors to split the main line and extend pipe to each room, something like this. But hold on, think about this. Is this setup really flexible for future changes? What if you decide to add it to a new room later? If you need to add plumbing to new rooms, you can't just magically make it happen, right? You do have to cut into the existing pipes, add another T connector, and extend from there. But wait, there's more to it. This kind of modification isn't just about cutting and adding pipes, it brings a whole bunch of challenges. Complex modification. Yeah, adding or changing plumbing like this isn't a walk in the park. It's complex and can really shake up your existing setup. It can mess with the water pressure, yielding uneven water pressure to different outlets. Got a leak or a blockage? Good luck figuring out where it's coming from. Without separate controls, it's really hard to figure out. More connections mean more chances for leaks. It's headache waiting to happen, with more maintenance and repairs down the line. So, can you say that this design is open for extension without much impact to the existing design? Absolutely no, right? So in this real-time example, we can clearly say that this design does not follow OCP. The moment you need a new connection, you have to deal with existing water flow. So now, let's see a simple design change and see if the design becomes open for extension and closed for modification. What if we use something called a pipe manifold? The main water line comes in here and can go out through any of these outlets. Let's say at first you are just using two of these for your kitchen and bathroom, but then you build a new room and need water there too. With the manifold, you don't have to go through the hassle of cutting existing pipes and adding a T connector. Instead, you just pick one of the unused outlets and boom, you have water in your new room. Easy, right? Plus, there is a cool knob that lets you control the water flow to each outlet. Got a problem in your pipes? No worry. It's just easier to find and fix the issue with this kind of setup. Without manifold, your plumbing's like a big confusing puzzle with T connectors everywhere and no real order. But with manifold, it's like you have tidied up the mess and saved yourself a bunch of headache and cost down the road. It's perfect example of a design that's ready for new additions without messing with the existing setup. Pretty neat, right? Hmm. We have discussed a lot about a real world problem. So what does all this have to do with software and the open close principle? You must be asking this question, right? Let's write some code and discuss what happens if we ignore the open close principle while writing our code. I'll be using Shisha for my example. In the interest of time, let me quickly write some code that generates reports based on a report type and come back. So, this is a report generator class. It has a method generate report which takes a parameter report type. Depending on the report type, it generates the report. So if the report type is PDF, then it generates PDF report. Right now, just displaying a message. Else, if the report type is Excel, then it generates the Excel report. Let me call this method from our main method. Let me call generate report. Let's generate PDF report. Let me run this. Works fine. Let me generate Excel report. So it works fine as well. Now, what's the problem with this approach? It actually violates OCP. Let's suppose tomorrow you have to generate a word report. The generate report method must be altered to accommodate this new report format, right? Just like our plumbing example, when you needed a new connection, you have to make a change to the existing design by cutting the pipe and fixing a T connector. Let's add a code for new report type. Say word file. See, what did we do right now? We have added something to the existing class, which means your class is not closed for modification, rather open for modification. And what does OCP tells? Your class should be open for extension and closed for modification, right? The code works perfectly though. However, there are many underlying problems. Let's list down few of those. Reduced flexibility and scalability. Not adhering to OCP often results in a design that is not flexible enough to accommodate future changes or enhancements. Look at this code. Doesn't it seem complex with numerous conditions? In a real time scenario, you could end up building hundreds of lines of such code in each of these conditions, which can greatly increase complexity and make your code highly inflexible. This lack of flexibility can hinder the scalability of the software, making it difficult to adapt to new requirements or technology changes without significant rework. Remember our plumbing example? Cutting into the existing pipe every time and adding a T connector leads to significant issues in the future. It can definitely lead to increase in regression bug. Every time existing code is modified, there is a risk of introducing new bugs. These bugs are often hard to predict and can lead to decrease in overall software reliability. Higher technical debt. As we know, continuously modifying existing code for new feature contributes to technical debt. Over time, this debt accumulates, making future changes even more costly and time consuming. It will add to definitely difficulty in understanding and integration. A code base that is not structured according to OCP can become complicated and hard to understand. I hope you have at least little idea that what problems you might encounter if you do not keep your code closed for modification and open for extension. Now, let's refactor this using OCP. Please do remember that having a good understanding of polymorphism makes this easier to understand. If you want to refresh your knowledge on polymorphism, please follow my video on it. The link is given in the description. Let me ask you a question. Can you think of the generate report method in a way that every time you ask to generate a report, it simply directs the call to an appropriate class? For example, if you are asking for a PDF report, then it directs to the PDF report generator class. And if you ask for Excel report, it directs to the Excel report generator class. If you have new types of reports, you simply implement them in a new class, essentially extending it to a new class without changing the report generator method. If you can achieve this, don't you think that this class will be open for extension and closed for modification? Remember, Designing your system in a way that allows for adding new functionalities through new classes instead of modifying existing ones can always significantly reduce the risk of introducing bugs. For writing such code, you must have good understanding of interfaces and interface-based polymorphism. I again highly recommend watching my details and straightforward videos on these topics. Now let's refactor our code. The idea is whenever generate report method is called, it should call the respective generate method of the class instance it receives. Let's design the generate report method first. Let me create an interface called iReportGenerator. Let's have a method called generate here. Now let's create a constructor for the report generator class and receive iReportGenerator as a parameter. Let's create a class level variable for this. Let me comment this if else statement. Now in the generate report class, if I call report generator.generate, what do you think? Which generate method will call? Obviously the method from the class whose instance has been passed here, right? Are you getting it? It looks a little confusing as we have not created the class that implements iReportGenerator. Let's create a few classes that implement iReportGenerator. Let me create and come back. So, I have created two classes that implements iReportGenerator. Now let me call generate_report. Let me pass the instance of PDF report generator. Let me debug this. So it comes to generate report method. See, the report generator is PDF report generator. So it goes to PDF report generator class. So it generates PDF report. Now let me pass Excel report generator instance. See, it calls Excel report. Let's list down few of the benefits of following this approach. In this approach, adding a new report format, say a Word or HTML, would be as simple as creating a new class that implements iReportGenerator interface. This design allows the system to be easily extended with the new functionalities while keeping the existing codebase stable. Let's see that. Say I want to add Word report generator. So should I require to add code in the existing classes? Absolutely no with this approach. We add this functionality in completely new class. Let me create a word report generator class. Let's implement iReportGenerator. Now to generate word report, just use the instance of word report generator. That's it. As simple as that. As discussed earlier, adding new functionalities to a new class offers a huge benefit. It lowers the risk of bugs. It reduces the risk of introducing new bug as existing classes remain unchanged. As the report types are added as separate classes, the system is more maintainable and scalable. There could be more such example. Let me write one more and come back. See this logger class. The logger class is tightly coupled with the console output, limiting its functionality, right? If you wish to change the logging target to a database or network, you need to modify this piece of code. So, not closed for modification. Let me ask you this question. How can we refactor this code so that it adheres to OCP? Can you comment and let me know? Let me discuss a little more on the main purpose of OCP. Now, mostly an OCP design uses a common interface, and different subclasses implements this interface to provide specific functionality. The decision of which subclass to instantiate and use often depends on certain conditions or requirements in the application. However, the key aspects to understand here is that the open close principle is fundamentally about achieving two main objectives. First one is extensibility, which means the ability to add new functionalities or components to the software without modifying the existing code. And the second one is maintainability, keeping the existing code base stable and unchanged, reducing the risk of introducing bugs when new features are added. Okay, let me tell you few concepts required to implement OCP. First one is interface and abstract classes. As mentioned earlier, The use of interfaces and subclasses is a common way to realize these objectives in object-oriented programming. By defining a common interface, you can extend the functionality to your applications with new subclasses that implements this interface. Hence, this approach avoids modifying the existing code, thus adheres to the OCP. Let me ask you a question. Interface or abstract class? Which one would you prefer for OCP? Concepts of events also at times helps writing code that adheres to OCP. You could design a system where new event types and their handlers can be added without changing the existing event processing logic. You can watch this video to understand how you can achieve OCP using events. Many design patterns facilitates OCP like strategy, factory, decorator, and observer patterns. These patterns can be applied in various contexts. If you are interested in design patterns, do watch my design pattern series, where I have explained these design patterns in detail. Please also do comment and tell me what's your favorite design pattern that you feel complements OCP. That's all for today. I hope you found the information and examples helpful and easy to understand. If you have enjoyed the video, please don't forget to subscribe the channel and leave your comments for all the future videos on C Sharp and other technical topics. Thanks.